The derivative of e to the x is the same form as a to the x. This is because this is a special way to do a derivative where it's a constant to the value of a function or a variable. So a to the x, the derivative of this will be a to the x ln of a, as long as a is a constant and the x is a variable. So e is just a constant. It's 2.7 something something something. That's not important. But if you see, we can put e to the x in the same form as a to the x because it follows the same rules of a constant to a variable, e to the x, which becomes e to the x ln of e. But if you know your ln rules, you'll know that ln and e cancel each other out, meaning that the derivative just becomes e to the x. So the first example is of e to the 3x. This may look simple, but it is. So to start, you notice that it will follow the same rules as the chain rule. It's e, which is a constant, to a function of 3x with a variable. So e to some sort of value is going to be your first function. So let's call it e to the b. We'll say 3x is equal to b. So now this will become e to the b ln of e, which, as we discussed before, cancels out. So the first part of the question just stays e to the 3x. Now, because of the chain rule, we know we have to do the derivative of the inside of the function. But the derivative of 3x is just one of the ones we've done before, where the x has the value 1, so the 1 will come down in front, multiply with the 3, subtract 1, which gives you x is 0, which just gives you 3. So now you multiply it by 3. So to finish up, you'll have 3e to the 3x. And then you're done. So now we have this problem. This problem starts off looking pretty difficult because of how many steps there is, but it's not that bad once you start thinking about it. Slow it down. So to start off, we're going to have 4, which we'll take out because it's just a constant, and we know that we can take that out when we're doing our derivatives. So now we have e to some sort of function up there, which we'll just call b again. So now from the last part, we know that'll be e to the b ln of e, which will cancel out, and we'll just come back to e to the b. So that's the whole first part. Now we got to do the chain rule, which is going to be the derivative of whatever's inside of the bracket, or whatever's the value of b, which is going to be the derivative of 4 sine x plus e to the 4x. So 4 sine x just becomes 4 cos x because of trig, where sine x, the derivative becomes cos x, and the derivative of cos x becomes negative sine x. Now, all we have to do is plus e to the 4x. Well, it's going to be the same thing as we did before. It'll be e to the b, which becomes e to the b because of the ln e. Now, multiplied by the inside, which is 4x. 4x, the x will go away because of the differentiation rules, and it'll just be 4. So it'll be 4 e to the 4x. Now, I'd like to put that in front and make the b the original function to clean it up. So equal 4 cos x plus 4 e to the 4x, all multiplied by e to the 4 sine x plus e to the 4x.